Do we truly have control over our choices and actions, or are our lives predetermined? This question has captivated philosophers and scientists for centuries. Many argue that our universe operates under deterministic laws, suggesting that every event is a consequence of prior events. This notion seems to contradict our deeply ingrained sense of free will, the feeling that we are the authors of our own destiny. We make choices every day, big and small, and with these choices comes a sense of responsibility and agency. How can our subjective experience of free will be reconciled with the seemingly deterministic nature of the universe? What if there is an explanation? What if our ability to make choices, to exercise free will, arises from the very same laws of nature that appear to deny it? Can we figure out what internal processes could empower us to generate new ideas and to form free and creative decisions? Let's have a look how the nature itself has done it. Enter so-called evolutionary or genetic algorithms. Evolutionary algorithms offer a powerful framework for understanding how complex systems can change and adapt over time. Inspired by natural selection, these algorithms mimic evolution to find optimal solutions to any problem. Just as nature favors organisms with traits best suited to their environment, evolutionary algorithms favor solutions that best address the problem at hand. This process unfolds through a continuous cycle of variation, selection, and inheritance. First, a diverse population of candidate solutions is generated. The best performing solutions are then used to create the next generation, inheriting the characteristics that made their predecessors successful. The human brain, with its billions of interconnected neurons, is arguably the most complex system known to mankind. It is constantly changing, adapting to new experiences, and learning from its mistakes. This dynamic nature of the brain suggests it might operate using principles similar to those found in evolutionary algorithms. Imagine the brain as a vast landscape of interconnected ideas, thoughts, and potential actions. Within this landscape, new ideas constantly emerge, representing the variation stage of the evolutionary algorithm. These ideas are then evaluated and filtered, leaving only the best ones for the next iterations. Could this continuous cycle of variation, selection, and inheritance within the brain be the driving force behind our capacity for free will? Imagine for a moment the birth of a new idea. It could be a fleeting thought, a burst of inspiration, or a solution to a problem that had been nagging at the back of your mind. This spark of novelty is the essence of variation within the brain's evolutionary algorithm. Just as mutations introduce new genetic variations in biological evolution, these novel ideas inject unpredictability into our thoughts and actions. These ideas can arise from external stimuli or bubble up from the depths of our subconscious. Each new idea represents a potential path forward, ensuring our minds remain flexible and adaptable. Within the vast network of our brains, countless ideas compete for attention, like a chorus of voices vying to be heard. Some ideas are loud and insistent, demanding immediate action, while others whisper subtly, their implications slowly revealing themselves over time. This cacophony of thoughts reflects the richness and diversity of the brain's internal landscape. Through a process akin to natural selection, the brain evaluates these competing ideas, favoring those that align with our goals, values, and past experiences. Our emotions, biases, and unconscious desires can all influence which ideas rise to the forefront of our consciousness. This subjective element of selection gives rise to the uniqueness of individual thought patterns and behavioral responses. Our past experiences, encoded within the intricate web of our memories, play a crucial role in shaping the variation of ideas within our minds. Every interaction, success, and failure leaves an indelible mark on our neural pathways, influencing future thoughts and actions. Memories serve as a vast repository of information, a database of past experiences that the brain can draw upon when generating new ideas. When confronted with a novel situation, the brain searches for similar experiences stored in memory, attempting to find patterns and extract relevant information. This process of pattern recognition is essential for making sense of the world and predicting the likely outcomes of our actions. However, the brain's reliance on past experiences can also lead to biases and limitations in our thinking. One of the most intriguing aspects of the brain's internal evolutionary algorithm is its inherent unpredictability. While our past experiences and genetic predispositions influence the types of ideas we generate, they do not dictate them with absolute certainty. There is an element of randomness, a touch of chaos, that infuses the process of variation, making it impossible to predict with complete accuracy what thoughts will emerge. This element of unpredictability is crucial for creativity and innovation. If our thoughts were entirely determined by our past experiences, we would be incapable of generating truly novel ideas or breaking free from established patterns of thinking. It is the unexpected connections, the sudden leaps of insight that drive progress and push the boundaries of human understanding. The human mind, a ceaseless generator of possibilities, presents us with a constant stream of choices, both trivial and profound. Each new idea, each potential action, is weighed and evaluated in the balance of our internal selection process. Like a master strategist, the brain assesses the potential risks and rewards of each option, attempting to anticipate the consequences of our choices. This evaluation process draws upon a vast network of interconnected brain regions, each contributing its own unique perspective. The prefrontal cortex plays a crucial role in weighing the long-term consequences of our actions, while the amygdala injects a dose of gut feeling into the equation. This intricate interplay of reason and emotion ensures that our choices reflect our values, desires, and fears. Emotions, often viewed as the antithesis of rational thought, play a crucial role in the brain's selection process. Our feelings serve as powerful motivators, shaping our perceptions, influencing our judgments, and ultimately guiding our choices. While we may like to believe that we make decisions based on logic and reason alone, our emotions exert a powerful influence on our thoughts and actions. Consider the feeling of fear. When confronted with a perceived threat, our bodies flood with adrenaline, preparing us for a fight-or-flight response. This surge of emotion, though essential for survival, can also cloud our judgment, leading to impulsive decisions. The key to harnessing the power of our emotions lies in recognizing their influence and developing the ability to regulate their intensity. Our values, those deeply held beliefs that shape our perceptions of right and wrong, play a fundamental role in the brain's selection process. They are the product of a complex interplay of factors, including our upbringing, cultural background, personal experiences, and genetic predispositions. These values serve as filters through which we evaluate the world, influencing our judgments and actions. Closely intertwined with our values are our desires, those yearnings for experiences, possessions, or states of being that motivate us to act. The interplay between our values and desires is a constant negotiation between what we believe is right and what we want in the moment. This internal struggle is at the heart of many ethical dilemmas, as we grapple with choices that pit our principles against our desires. The notion that our brains operate according to an evolutionary algorithm raises intriguing questions about the nature of free will. If our thoughts and actions are the product of deterministic processes, shaped by our genes, experiences, and the workings of our brains, can we truly be said to have free will? The answer is a resounding yes, even if the deterministic nature of the universe suggests that every event, including every thought and action, is a consequence of prior events. Even in a purely deterministic universe, random mutations used in the evolutionary algorithm destroy any predictability of the outcome. Then there is a well-known many-body problem, which makes calculations progressively hard and impossible as the number of bodies increase, even in a fully deterministic universe. And finally, our universe is not quite deterministic. It is quantum. Probabilistic nature of the laws of nature is ingrained in the basic setup of our reality. This perspective leaves little room for any determinism or predictability of our decisions. Even under exactly the same initial conditions, we may come up with different ideas each and every time. Most of the time, our ideas will be quite creative and well-structured, leaving us the proud and undisputed authors of them. This matches perfectly with our subjective experience of the world, the feeling that we are the authors of our own thoughts and actions. Thus, Our deeply ingrained sense of free will is very easy to reconcile with the cause and effect view of our universe. The human brain, a master of pattern recognition, is constantly seeking order amidst the chaos of experience. It excels at identifying recurring themes, connecting seemingly disparate events, and extracting meaning from the torrent of information that washes over us daily. This drive to make sense of the world is a testament to the brain's remarkable capacity for learning and adaptation. By identifying recurring patterns in our environment, we can anticipate future events, predict the consequences of our actions, and navigate the complexities of the world with greater confidence. The ability to learn from experience and adapt our behavior based on past successes and failures allows us to thrive in an ever-changing world. Successful patterns of thought and behavior, those that consistently yield desirable outcomes, are reinforced and strengthened, becoming increasingly likely to be repeated in the future. Life is a continuous learning experience, a never-ending cycle of trial and error. Each decision we make, each action we take, provides valuable feedback that shapes our future choices. Successes, no matter how small, reinforce our beliefs, validate our strategies, and encourage us to continue down a particular path. Failures, on the other hand, though often painful in the moment, offer invaluable opportunities for growth and learning. The brain, ever the efficient learner, is exquisitely designed to extract wisdom from both our triumphs and our mistakes. When we succeed, the brain releases a surge of dopamine, a neurotransmitter associated with pleasure and reward. This dopamine rush creates a positive feedback loop, strengthening the neural connections associated with the successful behavior and making it more likely to be repeated in the future. Failures, though initially met with disappointment or frustration, trigger a different but equally important learning process. When we make a mistake, the brain activates the anterior cingulate cortex, a region involved in error detection and conflict monitoring. This activation signals the need for a course correction, prompting us to re-evaluate our strategies and consider alternative approaches. Our beliefs, those deeply held convictions that shape our understanding of the world and influence our every thought, feeling and action, are not static entities etched in stone. They are dynamic, ever-evolving constructs, constantly being shaped and reshaped by the influx of new information, the reinterpretations of past experiences, and the ongoing dialogue between our internal world and the external environment. This process of belief formation and evolution is inextricably linked to the brain's evolutionary algorithm. Just as genetic mutations introduce variations into the biological gene pool, new experiences, insights, and perspectives can alter the landscape of our beliefs, challenging our assumptions, expanding our horizons, and prompting us to revise our understanding of ourselves and the world around us. This inherent flexibility in our belief systems is essential for adaptation and growth. A rigid adherence to fixed beliefs, an unwillingness to question our assumptions or consider alternative perspectives, can lead to stagnation, intolerance, and an inability to cope with the inevitable uncertainties and complexities of life. By remaining open to new information, by cultivating a healthy skepticism towards our own beliefs, we foster intellectual humility, encourage empathy and understanding, and create the space for personal growth and transformation. Every thought we think, every idea we entertain, leaves an indelible mark on the vast neural network of our brains. Like tiny rivulets carving their way through the landscape, our thoughts create pathways, strengthen connections, and shape the very architecture of our minds. This intricate web of neural pathways, constantly being molded by the ebb and flow of our mental activity, becomes the repository of our experiences, the embodiment of our unique perspectives, and the foundation upon which future thoughts and actions are built. This legacy of thought, this cumulative impact of our mental lives, is the essence of inheritance within the brain's evolutionary algorithm. The thoughts we entertain today, the ideas we embrace or reject, influence the thoughts that will arise tomorrow, shaping the terrain of our minds and influencing the trajectory of our lives in subtle yet profound ways. This process of inheritance is not limited to the confines of our own skulls. Through our interactions with others, through the sharing of ideas, stories and experiences, we transmit our thoughts and beliefs into the world, influencing the minds of those around us and contributing to the ever-evolving tapestry of human consciousness. The ideas we express, the values we espouse, the knowledge we share, have the power to ripple outwards, shaping the thoughts, beliefs and actions of others long after we're gone. As we've journeyed through the intricate workings of the human brain, we've uncovered a remarkable truth. Within the forces of determinism and randomness lies the potential for genuine free will. Our brains are dynamic systems, constantly adapting and shaping our perceptions, thoughts and actions. Each experience and interaction leaves its mark on our neural pathways, influencing the thoughts we think and the choices we make. This tapestry of choice, woven from our genes and experiences, makes each of us unique. Our capacity for free will, though constrained, is a testament to evolution's power to create complexity and genuine agency. The symphony of free will arises from the intricate interplay of countless neural processes, each contributing its unique melody. Our genes provide the initial score, influencing our predispositions and potential. Experiences act as the conductor, shaping the interpretation. Chance introduces improvisation, ensuring uniqueness. Within this symphony there is room for both determinism and randomness. This emergent symphony is a testament to evolution's power to create order from chaos. The question of free will, much like the universe itself, is vast and complex. Our capacity for choice is a fundamental aspect of the human experience. The evolutionary algorithm within us makes free will possible. We adapt to challenges and carve unique paths through the world. The existing universe provides the canvas for our life's masterpiece. Randomness infuses our journey with adventure, reminding us that the future is a story waiting to be written. Be free, be creative, remember. Our lives, our destiny and our future creations are not already encoded. They are not encoded in the initial conditions of the Big Bang.